So we're starting chapter 3, and chapter 3 is about bivariate data. So let's just run forward with it, and here we go. So scatterplots, that's how we basically graph paired data. And so just like with any other research situation, we started with univariate data with just single observations. Now we're moving into paired observations. We just need to set the whole thing up properly. So what individuals are we talking about? Are they cats, people, trucks? Who knows? Just depends on what you're researching. What exactly are the variables? What are we measuring? How are they measured? What are we comparing to what? You've got to let your reader or anybody who's interested in your work understand what you've done. Are the variables quantitative, or is at least one categorical? That's important. It just kind of will determine, what the nature of the process is going to be. This is going to be a tough one. Does one variable cause the other, or is there some other relationship between the variables? We're always interested in causation, but you can get really strong relationships between things that have nothing to do with each other. And you've heard the expression, correlation does not imply causation. All right, that's going to be a big deal here. What we would need to do to verify or to show causation is to perform an experiment. So pretty much what we're doing in this chapter is pre-experiment. Experiments will be in the next chapter. We're just going to, it's like preliminary research leading possibly up to an experiment. Okay, so these two things are pretty critical. Not because they're super hard, but because this is now the language of statistics for a bivariate setting. We have a response variable. You know it as a y variable or a dependent variable, and that's something that I will refer to not as a y variable or a dependent variable, but as a response variable. That's the way we say it in stats. The x variable that goes on the horizontal would be, of a scatter plot that is, would be your explanatory. Okay, we know it as an x variable or an independent variable, but not here. Okay, so it's pretty easy in most cases to get these things figured out. Not always, but say you're doing a study on heat in the environment versus amount of perspiration that an individual has. All right, well, the heat in the environment should explain how often or how much somebody perspires. So you would put heat on the horizontal axis. How much somebody perspires would be a response to the heat. So it would be the response variable, and it would go on the vertical or the y-axis. Not everything has a clear-cut relationship like this. We'll get to that in a moment. But explanatory and response. So what do we do when we gather this data? How do we start? Well, you always start with graphing, because graphing really does convey a lot of meaning. Even novices can look at it and see trends if they don't even understand the process. All right, so graph it, then drill down. See what kind of pattern is there. See if there's any, a small number of data points that are, deviating from that overall pattern. Why is that happening? Did you miskey something? Or do you have somebody from a population that mixed in with the one you're interested in that shouldn't be there? Or is it natural variation in data? Just depends. All right, so that's a pretty important step. The next thing would be to look at numerical descriptions. And we don't have mean, median, mode, standard deviation for this. But what we do have are things like correlation coefficient, coefficient of determination, least squares regression model, all of those things. But keep in mind that those show up like the third most important thing. It's really the picture that's going to aid us. We can actually have some things that don't really add up in our numerical descriptions if we just use those without the picture backup. And then just be able to communicate, which is, your main job, other than understanding statistics, is to get somebody else to understand it. So be able to, in a cogent way, say what's there. So our graph of choice is a scatter plot, which shows the relationship between two, it's quantitative, have to be quantitative variables that are measured on the same individual. So we may measure, the heat in the environment that a person is in, and then measure their perspiration amount, right? And get two numbers that are pretty much dependent on that one individual. And you do that for a number of individuals, and then you plot those points in an XY plane. All right, so your explanatory response relationship either variable may go on the horizontal axis. It's just if there's no explanatory response relationship. Where'd the no go? In any event, so we talked about the heat in the environment and then the perspiration rate, and that's pretty easy to assign to the horizontal and vertical axis, which variable goes where. But let's just say you've got something like the IQ of a male child versus the IQ of a female sibling. All right, it's like, which one is supposed to predict the other one? Or could one predict one way equally well as the other way? Well, if you have a case like that, then you can predict the explanatory, or you can assign rather the explanatory variable that you want, either one. All right, just if you have some kind of a prior research question and you definitely want to predict the girl from the boy, then you would put the boy on the horizontal and the girl on the vertical. Otherwise, you can just pick what you want. So yeah, that word no should be in there. Whoops, where'd it go? So when we're looking at scatter plots, we're going to look for the direction of the relationship. Really, we're starting with linear, okay? So we're looking for the direction of the relationship, the form, whether it's linear or not, the strength, how well it lines up to whatever, curve we're interested in, and then anything out of the usual pattern, the deviations or unusual features. So there it is. Direction is negative or positive or none. Form is linear or nonlinear, which, nonlinear is some kind of curve, maybe like exponential or quadratic. Strength. Strength is going to be the tough one because we may disagree between us about what it is. I may look at something and say, it looks pretty strong. And you may look at it and go, it looks kind of moderate. It's sort of an opinion thing. So we're going to have to accept a little bit of leeway in how you, determine or how you define the strength of a relationship. And then your unusual would be outliers or influential points. We're not really going to focus in on those two things for a few days, I don't think so, but we will. So here is one type. It's a positive association because it's looking like a positive slope, low on the left, high on the right, lining up to a line fairly closely, so linear. And note the nature of the relationship. I could ask you for the what the relationship is, and you would probably say positive, linear, and fairly strong. But the nature of the relationship's a little different. So keep that in mind, that that's actually a separate question. As X increases, so does Y. All right, so, and you may need the context here. This just doesn't have any context, but if there is context, as the heat increases, so does the rate of perspiration. So context is pretty important. So positive, linear, and strong. Here is negative and linear and strong. So here as X goes up, Y is going down. And again, if you have the context, that's a good thing. Okay, well, what if you have something that looks like sort of a circle or a ball like this? This is no relationship. because y is just behaving randomly as x increases. So as x goes up, sometimes y is low, sometimes y is high, sometimes y is in the middle. It's just behaving in a kind of haphazard way. So no relationship. Okay, here is a weak positive linear association. Yeah, it's not correlation. Correlation is a number summary, so please use relationship or association, but not correlation. That's just not good usage for the terminology. So we've got a few things kind of outside the overall pattern, but if you look at it, you can see it lining up like this, but not terribly strong. Right? It's not really going to, any line of best fit you put in here, you're going to have a pretty big scatter around it, so that's weak. Here's a weak to moderate. This is a little bit sort of, could go one way, could go the other. It doesn't look quite, the more it looks like a circle, the weaker it is. And this looks like it's lining up pretty well. So if you said weak or if you said moderate, I think I could buy either one, but it definitely is negative. Okay, this is curvilinear, right? It's not fitting really well to a straight line. And don't try to cram a straight line into something that's curved. All right, so this is just a pretty strong nonlinear relationship. The points are lining up pretty well to the curve, but it's just not straight. Okay, an outlier is any point that deviates from the overall pattern. Here's an example of one. And typically outliers are going to deviate in a vertical kind of way. All right, we'll get to the influentials later. Those tend to deviate in a horizontal way, although you can kind of get both, but we'll save that for another time. All right, so what if you have different categories? You gather some data and you realize, hey, there's some difference between this subgroup and this subgroup. Well, you can indicate the subgroups with marks. You can do solid and open points. You can do solid points and little crosses. You can do crosses and squares, So if you do have two categories like we do here, you can go ahead and indicate them separately as such, and that's fine. And you may be able to accumulate some meaning for both separately. Okay, so here is an example that's in your packet. It's like on page 1, and so this is the data for it, and I'm not going to sit here and construct this by hand right in front of you, or go for this thing while I type it in while you sit there and snooze. I've already got it typed in, but let's just look at this. First of all, the year here and here, these are just like identifier variables. We're not going to put those in the scatter plot. If we do something exponential later on, then we will use the year, but not here. This is just saying in this particular year, we have this many powerboat registrations in the thousands and this many manatees killed in the area that we're studying, okay? So really, we're going to use the powerboat registrations as an explanatory variable and the manatees killed as the response. I doubt seriously if you would get people in 1979 that would say, oh, hey, 24 manatees were killed, let's get a powerboat, right? It's the powerboats that we can assume are driving the manatee deaths. There may be other things, but, just the basic explanatory response, powerboat registrations go on X, manatee kill go on Y, okay? All right, so this is what we're going to end up with in a scatter plot. Now, this was generated with technology, and you've got scales here. The powerboat registrations are explanatory, manatees killed a response, nice straight lines, so don't do this without a straight edge. Here's a title, and you don't have to start at 0, because if you do, this will shift way over to the right and it will just look funny. So wherever you have data starting, that's where you want to start on your axes, and wherever it ends, that's where you want it to end. Okay? So this is fairly strong positive linear association between boat registrations and the number of manatees killed. See how I used the context? And here's the nature. As boat registrations increase, the number of manatees killed also increase. Okay, so this is homework, but I do want to show you the calculator steps. So let me close this out and open up. I'm going to start out with my Nspire here, and you can see that I've loaded this up, and you definitely want to name your variables. So registrations, manatees killed, just something you can do with X and Y if you want, but just so long as you can keep track of what's what. Put this in and keep in mind that you need these two things to end at the same spot, like at row 14. So if you have a value in row 14 and nothing beyond that, but you have a number in row 15, you're going to get an error because these have to be paired. And when you put them in, you definitely want them, with both pairs that are related to the year. In other words, you don't want 447 and 21 or 460 and 13. That's bad. So let's quit out of here and go to a stats graph. And remember, the explanatory was the registrations. Whoop. And we'll do the manatees killed as the response. And there it is, all right? Positive, linear, fairly strong, I would say. Okay, I don't see any particular deviations or anything to comment on. So I'm pretty happy with that, okay? And let's go to the other calculator and check that out. So I should have the data in here. Again, they end in the same line, at 14. So I'm going to go ahead and quit out of here and open up a graph. Okay, my plots are off. So I need to turn my plot on. And remember that this was a normal probability plot. So the very first one that's highlighted is a scatter plot. My X list is L1, that is the registrations. My Y list is L2, that's the manatees killed. You can choose the mark you want. If you're going to do this with a mixed mark, you can go ahead and just split up the categories and do two scatter plots at once, and they will mix the marks together. But for right now, let's just look at a basic, and we'll choose that, and then we'll graph it. And naturally, you don't see it because you're not scaled right. We're just in the kind of default scale. So let's zoom 9 for stats, and there it is. It's the same thing. Okay, you don't get all the little clever labels, and you don't see any animation or anything, but it's a perfectly doable scatter plot. So, all right, the last thing I want to show you before I cut you loose is what it looks like on page 1. All right, so you saw me with the data in, you ignore the year, and powerboat registrations we determined is the explanatory variable, manatees killed is the response variable, and here is mine drawn by hand. Now, I would suggest you use graph paper. At the very least, I would suggest you use lined paper. I did this without either one, and it looks great, okay? You just take a little bit of time and make it look good. You want to draw a 90-degree angle like this, and you want it straight, and start wherever the data starts and end where it ends. Same thing for this. Put your labels on here. Put your title on here, and if you very carefully plot these things, it will look fine. So the relationship between powerboat registrations and manatees killed is positive, linear, and strong, right? Got the context, and I mentioned the three things. And then the nature of the relationship is as your powerboat registrations increase, your manatees killed also increase. All right, and that's what I said here. So that's kind of what you're going to do for a couple of the problems in the homework. I would definitely practice them in your calculators first. but then you can draw them and you'll know what they look like ahead of time. That is going to be for scatter plots on our first day in chapter 3. So I'm going to bid you a fond farewell, and we will look at correlation tomorrow.